I don't get any of this. What even is the first fundamental theorem of calculus?
I can help you. To the whiteboard.
All right, so we're going to start it pretty basic. We're going to find the area under the curve of x squared, and we've got bounds of 1 to 4. So now we're going to want to take the antiderivative of x squared. So what we're going to do is we're going to add 1 to the exponent, giving us 3, and then we're going to divide the entire thing by 3. So we're going to end up with x to the third over 3, and then we got to remember we have these bounds of 4 to 1, which we've got to leave here. Now, remembering this, that f of b minus f of a equals the integral solved, we're going to want to do that. So, you'll get, substitute 4 in, so you'll get 4 to the third over 3 minus f of a, which is, you're plugging in 1, so you get 1 to the third over 3. So then, solving that, 4 to the third power, that's 64. So 64 over 3 minus 1 cubed, which is pretty difficult, but it's 1. And you do 1 over 3, you'll get 63 over 3.
Oh, so you do substitution business. I get it.
All right, so example 2, we've got the area under the curve of x plus sine x. So we've also got bounds of 0 to pi. So first, we're going to want to take the antiderivative of x plus sine x. So that'll be 1 over 2 x squared. And then antiderivative of sine x is negative cosine x. So minus cosine x with those bounds of pi to 0. Next up, we remember our favorite rule, f of b minus f of a gives you that integral. So let's do that. Let's plug in the b. So we'll get 1 over 2 pi squared minus cosine of pi. Now, we subtract by plugging in the 0. So we get 1/2 0 squared minus cosine of 0 plus. Now, we simplify. So, 1/2 pi squared, I'm going to leave it like that, minus cosine of pi, so that is -1, but we make it +1. And then we've got minus 0, so that's 0, plus cosine of 0, which is 1. So I add a 1. So my answer that I'm left with is 1 over 2 pi squared plus 2. And you can plug that in the calculator if you'd like. Alright, so now we've got 3 problems for you to work on. Go ahead and pause the video and work them out, and you'll see if you got the same answers as me. Here's the answers. Take a look. Hopefully you got the same as me. Otherwise, I would practice more.
Okay, I think I got the same answers, but is there a second fundamental theorem of calculus?
Yes, there is a second fundamental theory of calculus student who has the same last name as me. So with the second fundamental theory of calculus, you want to know that if f of x is continuous on an open interval, then the derivative of the integral of f of t will be f of x. Now, I'm going to give you some practice problems. So for the second fundamental theory of calculus, we've got a practice problem. So let's work it out together. So we want to find the derivative of this equation. So we're going to take the x squared and plug it in for the t. So we're going to get -2 times x squared plus 2. Take this whole thing and multiply it by the derivative of x squared, which is 2x. There you go. By the way, this is a constant, And the derivative and the integral will cancel out, so what you will have to do is plug in the x value. We don't care about the constants. Okay, here are 3 practice problems for you to do. Keep in mind number 3 is kind of tricky. Now pause the video, and then unpause it. Not yet, and then tell me if you got the same. Alright, now unpause the video, which you must have already done, and hopefully you got the same.
I finally understand the theorems in calculus.